In this lesson, we're going to recall the definition of an induced subgraph. We're going to use this definition of induced subgraphs to define graphlets. And we're going to see some examples of how you use graphlets to assign weights to vertices in a graph. So an induced subgraph. A subgraph can be induced by selecting a subset of the vertex set, or it can be induced by selecting a subset of the edge set. We're interested in a subgraph induced by vertex set in this lesson. So if we select the two vertices B and D, then what is the induced subgraph? Well, we have the two vertices B and D, but notice that B and D are not adjacent. Therefore, they do not induce an edge. And the subgraph induced by B and D is simply the two vertices B and D. If we take another example and we select the subset A, B, and C, then we have the three vertices A, B, and C. And since all A, B, and C are adjacent, the induced subgraph is the triangle A, B, and C with three edges. Likewise, A, B, and C is again an induced triangle. But if we select the vertices A, B, and D, as we've already noted, B and D are not adjacent. So the induced subgraph, when we select A, B, and D, is a path of length 2. The path of length 2 is beginning at B. We go B to A to D. Just to be sure, we'll take a larger example because we're going to be using this example for our next topic. So let's take the vertex set 1, 3, and 5. What is the graph, the subgraph induced by the vertices 1, 3, and 5? Again, here, 3 and 5 are not adjacent in the same way that B and D were not adjacent in the preceding example. So the vertex set 1, 3, and 5 induces a path of length 2. Notice that 1 is adjacent to 3 and 1 is adjacent to 5. So if we were to traverse this path of length 2, we could go from 3 to 1 to 5. We could not go from 1 to 3 to 5. So even though we selected the set 1, 3, 5, the order in which we traverse is going to make a difference in our next example. So graphlets were introduced by Natasha Przul in a paper called Biological Network Comparison Using Graphlet Degree Distribution. She labeled each vertex with its degree, which was a vector of length 73, and then looked at the distribution of these degrees in various networks. Many people have used graphlets since then. It's been a popular tool. We're also going to use graphlets in the application section of this course. So these are the first 4 graphlets. The first graplet, there's one distinct node, so it's labeled 0. Starting with 0, we count up. The second graplet has 2 distinct nodes, the central one and one of the peripheries. The third graplet, the triangle, it only has 1 distinct node, so it receives the next label of 3. And then in the fourth graphlet, once again we have 2 distinct nodes, one of the peripheries at one of the internal nodes of degree 2. So this process continues with 30 small networks. And by the time we've labeled all 30 small networks, we're up to 72. And since we started the labeling at 0, there are 73 distinct nodes. So what we want to do is we want to assign values to the vertices in our graph based on their graphlet role. So for demonstration purposes, let's look at the vertex labeled X. I've changed its label from 1 to X, so I won't confuse it with the graphlet node 1. So the vertex labeled X. Now I ask the question, how many times does the vertex labeled X appear as an end vertex of an edge? That is, how many times does it act like node 0? Since we have the edge x2, x3, x4, and x5, it is the end node of 4 distinct edges, and so the answer is 4. Notice that's the same as its degree, and that's why these are considered generalized degrees. The first graphlet answer is the same as the degree. So again, how many times does the vertex X appear in an induced subgraph when that induced subgraph is simply an edge? And the answer is 4. So we'll start a vector, and the first entry of the vector is 4. Now, the next graphlet is node 1. Node 1 is an end vertex of a path of length 2. So we say, how many times does the vertex X appear as the end node of a path of length 2? So we'll need 3 vertices. We'll need X and 2 other vertices. We cannot choose X2 and 4 because X2 and 4 generates a triangle, not a path of length 2. So we want to know how many times does X appear as an end node in an induced P2. If we can't choose X2, 4, in fact, if we look at all of the neighbors of 2, all of the neighbors of 2 are also adjacent to X. So if we choose X2 in any of its neighbors, the resulting induced subgraph will be a triangle. So we can't choose 2. If we choose 5 or 3, let's choose 3. So X and 3, and notice 3 is adjacent to 6. And 6 and X are not adjacent. So we can choose X3 and 6. And we can choose X5 and 6. And those two sets will induce, each one will induce a path of length 2 in which X is an end vertex. And those are the only ones. So the answer is 2. How many times does X appear in an induced P2 as an end vertex? And the answer is 2. Now we ask the question, how many times does the vertex X appear as the central vertex of an induced P2? And that is node 2 below. So how many times does X appear as a central vertex in an induced P2? We saw before that X3 and 6 induces a P2, but X is not central. So what we need is actually 3, X, and 5. If we select 3, X, and 5, we get a P2 in which X is the central vertex. But if that's the only vertex set that we can choose that induces AP2, where X is the central vertex. So for graphlet node 2, the answer is just 1. Since the vertex X behaves like node 2 in the graphlet only one time, then our third entry in our vector is 1. So when we're finished, what we would do is we would label the vertex labeled X. We would assign a vector to it. And the first 3 entries of the vector we have seen so far are 4, 2, and 1. The next graphlet node 3, we want to know how many times X is a node in an induced triangle. That counts fairly high, because we have x23, x24, x25, x34, and x45. So there are 5 distinct triangles that X appears in as induced subgraphs. So now our vector has another entry, which is 5. So in conclusion, we have recalled what we mean by we have recalled the definition of an induced subgraph, and then induced subgraphs are used to define graphlets. And we have seen an example of how you calculate the vector weight of a vertex based on graphlets.